we're going to talk about isosceles and equilateral triangles. So this top part is really just vocabulary heavy. So this is a good vocab piece, okay? This says the two congruent sides of an isosceles triangle are called legs. So this one is a leg and this one is a leg, since they're the two that are congruent. It also says that the angle where the legs intersect is called the vertex angle. So that's this one right here. Excuse me, I'm going to sneeze, I think. Excuse me. This is the vertex angle. Okay, and then we have the side opposite the vertex angle. That's if you go across from the vertex angle to the other side. That's supposed to be a dashed line, but there's the idea. If you go across there, that is the base. Okay, and the angles along the base are called the base angles. So those two are called base angles. Okay, everything has a name on here, but you will notice that some of them have duplicate names, right? Leg shows up twice, and base angles show up twice. We also have a solo vertex angle and a solo base. So it makes sense the two of them would have the same name because an isosceles triangle has congruent sides and congruent angles. So we have some things that are interchangeable there. Okay, with that knowledge, we can talk about the isosceles triangle theorem. It says this: if two sides of a triangle are congruent, that means it's isosceles, right? That's the definition of isosceles. Then the angles opposite those sides are congruent. Did you guys already know that? Since this side, this leg, is congruent to this one, then the angle opposite, those two angles are congruent to each other. So if you already knew that, cool. We're just reminding you. If you didn't, that's good info to know. So they want us to write an example. So we're going to say, if leg AB, segment AB is congruent to segment BC, then angle 2 is congruent to angle 3. That's taking this diagram that's up above and using it as an example to write what that rule means. Okay, now we're going to go and look at the converse of that theorem. The converse takes things in the opposite direction. So you might remember through proofs that we use the converse if we wanted to prove that lines were parallel, right? We would say, okay, given that we have some congruent angles, then we want to prove parallel lines. Well, in this case, we're going to say, okay, if two angles in a triangle are congruent, then we know that the sides opposite have to be congruent as well. So it's the same thing, it's just headed in a backwards direction. So we're going to say, if angle 2 is congruent to angle 3, then side AB is congruent to side BC, okay? So it's the same thing as what we said before, it's just headed in the opposite direction. So in either case, we can travel to the other thing. If they tell us we got congruent angles, we know we got two congruent sides. If they tell us we have two congruent sides, we know we have two congruent angles. That's how those ideas work. And we have a couple of examples here. Yay. Based on this right there, then we know that they have sides that are congruent. And one of the base angles is 68. Do you know which angle is the other base angle? It's angle J, and it also has to be congruent, so that's going to be 68 degrees as well. And they want us to find angle K. We could do that by taking 180 minus 68, right? And that would leave us with a 44-degree angle up there for angle K. Sweet. Let's try the next one. On this one, they didn't give instructions, which I wish they had. I think it should say solve for x. Okay. So right here, you can see that angle 74, 74 degree angle, 74 degree angle, those two are a match. That means we have an isosceles triangle, and that also means that the sides opposite, this side and this side, are congruent to each other. So to solve for x, we can set those expressions equal to each other. Subtract 3x from both sides and we get 6x. Add 73 to both sides and we'll get 96. Divide both sides by 6 and we end up with x equals 16. All right. Moving on, now we have equilateral triangles. A triangle is equilateral if and only if it is equiangular. If and only if tells us we can go in either direction. So if it is equiangular, then we know it is equilateral. If it's equilateral, then we know it's equiangular. Equiangular is a pretty weird word, right? This is saying equal angles. So all of the angles in this triangle are equal to each other. They're all congruent. If they're all congruent, can you figure out the measure of those angles? It would have to be 180 divided by 3, right? So I think that all three of these would be 60. And that's going to happen every single time we have an equiangular triangle. If the measures of A, B, and C are equal to each other, then triangle ABC is equiangular. Okay. And if all of the angles are congruent, then we know that all of the side lengths are congruent. So here's another word, equilateral. Equi means equal. Lateral is talking about the sides. One way you can remember that is if you do, like in weightlifting, if you do a lateral press, you're lifting the weights out to the sides, right? To the side of your body. So that's one way that you could think about it. So if these sides are equal, then triangle ABC is equilateral. If we have either that it's equiangular or equilateral, then we can go to the other thing just quick as can be, okay? So they both mean each other. If you have either of those pieces, then you know that you've got all the rest of it. Okay, so let's take a look at example 3. If triangle PQR is an equilateral triangle, solve for x and y. Okay, if it's equilateral, then we know a couple of things. We know that all of the angles are congruent. So we could write an expression for each of the angles of 7x minus 3 and 7x minus 3. There's another way we could do this. If we know that it's an equilateral triangle, then don't we know the measure of each of the angles? Remember what we discovered up here? If they're all the same, don't they all have to be 60? Oh my goodness, why isn't it writing? Okay, so we're going to say 7x minus 3 has to equal 60. Now, if you wrote that each angle had the expression 7x minus 3, and you added those all together, 7x minus 3 plus 7x minus 3 plus 7x minus 3 equals 180, you would still get the same answer that we're about to get here. So I'm going to add 3 to both sides. It's just a different way of thinking about it, and both ways are good. In fact, the way that makes sense to your brain, that's the best way to go. And it could be different per person, so it's all good to go. Okay, because all of the angles are equal to each other, then what do we know about all of the sides? They have to be equal to each other. And they gave us an expression for all three of them, but we only need 2 of them. Any 2 are equal to each other. So pick the 2 that you like. I'm going to choose the ones with the smaller y's. So I'm going to say 11y minus 23 equals 9y plus 1. We could have also done 11y minus 23 equals 14y minus 59, right? You could pick. So any 2 you can choose. They just gave us an extra that we don't need. I'm going to subtract 9y from both sides and I'll get 2y. If I add 23 to both sides, I'll get 24. And I think we end up finding that y equals 12. Okay, so over here, you're going to look for information that you can use regarding isosceles or equilateral triangles, and then try to find all of the stuff that's missing. Okay, good luck. Talk to you later.